Hello everyone, welcome to the video solution for mathematics. This is M1 paper from Solomon, paper L. Let's see. Question number 1. Two particles P and Q of mass m and km respectively are traveling in opposite directions on a straight horizontal path with the speed 3u and 2u. P and Q collide, and as a result the direction of motion of both particles is reversed and their speeds are halved. So direction reversed and speeds are halved. Find the value of K. Okay, so we have two particles. Particle P of mass m moving with velocity of 3u. I'm assuming it is moving leftward, and if we have another particle Q. So this is particle P, this is particle Q moving in opposite direction as that of P, and with the velocity of 2u, and mass of the particle Q is km, and they collide, and after their collision their directions is reversed, so P moves backward. This is P, and Q also reverses direction, but after collision their velocities are halved, so 3u, it becomes 3u by 2 and it becomes u, and you need to find value of K. So we'll have to apply law of conservation of momentum here. Again, you will have to take care of the direction of motion. Generally it is my habit to take positive direction or rightward direction as positive and leftward direction as negative. So for me, initial momentum of particle P is positive and initial momentum of Q is negative. That's convention I'm going to use here, and you can reverse the direction. So let's apply. So momentum before collision for particle P is 3 mu minus 2 kmu, and then is equal to momentums after collision. So momentum of particle Q, which is positive, so I'm taking it as kmu, and momentum of particle P after collision, so 3 by 2 mu. Now you can cancel all the similar terms, mu, and you have only 3 minus 2k is equal to k minus 3 by 2, and you have equation only in terms of k, so you can solve this equation for k. So you can say that this is 2k minus 2k comes here, becomes 3k is equal to this minus 3 by 2 goes over there, becomes plus 3 by 2, so 3 plus 3 by 2, so 3 and 1.5, so 4.5, that means 9 by 2, and then 3 and 9 gone, so k is equal to 3 by 2. This is the value of k. Part B, write down an expression in terms of m and u for the magnitude of impulse which P exerts on Q. So we need to find impulse on Q. That means impulse on Q, IQ, is change in momentum of Q. So the particle Q has mass km and into change in velocity. So the final velocity is u minus initial velocity. Initial velocity was minus 2u, and you simplify this, so you will have minus plus, so 3 kmu. This is the impulse in terms of k, m and u, but you need to give answer only in terms of m and u, so you replace the value of k. So IQ is equal to 3 times of 3 by 2, k had value 3 by 2, so 9 by 2 mu. This is the impulse on Q exerted by P. Question number 2. Figure 1 shows a plank AB of mass 40 kg and a length 6 meter, which rests on a support at each of its ends. The plank is wedge shaped, being thicker at the end A and then at and B. A woman of 60 kg stands on the plank at a distance of 2 meters from B. Suggests suitable modeling assumption which can be made about. In these types of question, we have assumption that whatever plank we are dealing with, either it is a uniform or a non-uniform, but you know that this is a wedge shape, so it is a non-uniform rod. So for plank, we can take assumption that it is a non-uniform rod, and woman is acting as a particle. These are the assumptions that we are going to make to solve our problem. Given that the reaction at each support are of equal magnitude, find the magnitude of the reaction on the support at A. So first of all, you need to see the situation and number of forces, because this is a wedge shape and non-uniform rod. The woman is standing at 2 meters from B, so this is 6 meter length, so 3 is here, so 2 meters is somewhere. So if woman is standing here and the weight of the woman is acting downward, and it is a force acting down, the weight 60 G. And there is another force acting on the plank, which is weight of the plank, and of course it is a non-uniform, so the weight or the center of mass of the plank will be towards a thicker end. So I'm assuming that this is the point where center of mass is acting. So this is the force. The mass of the plank is 40 kg, so this is 40 G, and we have two support forces, so this is the RB and reaction RA. So these are the forces acting on the system, and in our question we need to find the magnitude of the reaction on the support A. We need to find RA, that is our question mark. But the important point is they are saying that the reaction at both ends are equal, so RA equals to RB, because they have an equal magnitude, so you can say that it is R. Now we don't need to bother about the moment, because we have the forces up and down, and we know that the upward forces are equal, so we can say that the upward we have two forces, RA plus RB, that means 2R is equal to downward forces 60G plus 40G, so this is 100G, and then R is equal to 50G. So this is the normal reaction force at both ends, or at A, 50G. Part C, calculate the distance of center of mass of the plank from A. So you need to find the distance of center of mass. That means you need to calculate that distance. And suppose that this distance is X. So in order to find that distance, you need to consider the moment produced by the various forces, and in order to do so, you will have to take a point as a pivot, and it's your choice whether you take A as a pivot, or you take this woman position as a pivot, or B. It's up to you, because we have all the forces, so it doesn't matter what point we choose. So because we need to find X, so let's just take A as a pivot, because if you take A as a pivot, so there will be no moment due to RA. We would have only moment due to 40G, 60G and RB. RB we already have the value 50G. So if A as a pivot, you can see that the 40G is going to produce moment about A is like that, and it is a clockwise moment. 60G is also going to rotate clockwise, so we have a 2 clockwise moment, and RB is going to rotate or produce moment which is anti-clockwise. So we have 1 anti-clock and 2 clockwise moment. So you can apply the condition of the moment, and you can say that for so you can say that the moment about A, so 40 g times x plus another clockwise moment 60 times, it's not 60, why should it is 60g times distance, and you know that this distance, so the woman is standing at 2 meter, so this is 2, 6, so 6 minus 2, which is 4, 60g times 4. So these are clockwise moment is equal to anti-clockwise moment. So 50g times, what do you say, RB, of course it is 6. Again I forgot, it is G. And now you can cancel G if you wish, because we have a G in all terms. So G, G and G are gone. So 40x plus 240 is equal to 300. And then 40x is equal to 300 minus 240, which is 60, and 0 gone. So x is equal to 6 upon 4. That means x is equal to 3 by 2, which is equal to 1.5 meter. So center of mass is 1.5 meter away from the side A. That's your answer. Question number 3. Figure 2 shows a cable car C of mass 1 ton which has broken down. The cable car is suspended in equilibrium by two perpendicular cables AC and BC, which are attached to fixed points A and B at the same horizontal level on either side of the valley. The cable AC is inclined at an angle of alpha to the horizontal, where tangent alpha is 3 by 4. Show that the tension in the cable AC is 5880 Newton to find the tension in the cable BC. Okay, so first of all, you need to see how many forces are there. So you know that the weight of the cable car is acting down, and it is 1 ton. So 1 ton means 1000 kg. So this is 10 to the power 3 g, the weight of the cable car acting down. And we have a tension in both of the cable. Let's call the tension in the cable AC is T1. And the tension in the cable BC is T2. Tension will be different because angles are different. They cannot be same, because this angle is alpha and this angle will be 90 minus alpha, because we have a right triangle. This angle is 90 degree here, so we have 90 minus alpha. So you can resolve T1 and T2, its component, and then once you resolve, then you have a two equations in terms of T1 and T2, and then you can solve these two equations simultaneously to figure out value of T1 and T2. And how do you do that? So you can visualize T1 and its components, like if this angle is alpha, so you can say that if you see you have a horizontal line from here, something like this. This is a horizontal line like this. So you know that if this angle is alpha, this is also alpha, and this is 90 minus alpha, then that will also be 90 minus alpha. So same angle, this and this. Okay, now I am resolving T1 into its component, and you can visualize T1 as vertical component of T1 and the horizontal component of T1, like that, or adjacent component of T1, and you can say that this is T1 sine alpha. So this component is T1 sine alpha, and this component is T1 cos alpha. Similarly, you can resolve T2 into its component, something like this and this, and then it is T1, sorry, it's not T1, T2 sine 90 minus alpha, and this one is T2 cos 90 minus alpha. So first of all, you need to figure out value of sine alpha and the cos alpha. You know that the tangent alpha is given. Tangent alpha is 3 by 4. So 3 is opposite and 4 is adjacent. That means you can use this opposite and adjacent to figure out hypotenuse using Pythagoras theorem. So you can use Pythagoras theorem to figure out h. So h hypotenuse will be equal to 5 if you apply Pythagoras theorem. That means sine alpha would be equal to 3 upon 5, and then cos alpha would be equal to 4 upon 5. These are the values that you are going to use in place of sine alpha and cos alpha. What about sine 90 minus alpha? Remember, we have another trigonometric identity, that sine 90 minus theta or cos 90 minus theta. These are two important identity here. So sine 90 minus theta is cos theta and cos 90 minus theta is sine theta. That means you can say that this T2 sine 90 minus alpha is in fact T2 cos alpha, and this horizontal T2 cos 90 minus alpha is in fact T2 sine alpha. Now you can resolve the forces vertically and horizontally. So if you resolve forces, let's say vertically, or resolution vertically, so you have a vertical two forces acting, T1 sine alpha and T2 cos alpha acting upward, and which are balancing by the weight. So you can write here as T1 sine alpha plus T2 cos alpha is equal to the weight, which is 10 to the power 3g. So you can say that this is 1000 g. Moreover, you can substitute the value of sine alpha and cos alpha here. So you have sine alpha 3 by 5, cos alpha 4 by 5. So you can say that you have equation 3 by 5 T1 plus 4 by 5 T2 is equal to 1000 g. This is your equation number 1. For equation number 2, you will have to resolve forces into along the horizontal direction, and horizontally in the diagram you have only two forces acting, T1 cos alpha acting leftward and T2 sine alpha acting rightward. So you can say that because the system is in equilibrium, so T1 cos alpha equal to T2 sine alpha, or the better way is T1 cos alpha minus T2 sine alpha is equal to 0. And then again you can substitute the value of sine alpha and cos alpha. So you can say that this is 4 by 5 T1 minus 3 by 5 T2 equal to 0. Equation number 2. And now you can solve simultaneously equation 1 and 2. So for equation number 1, you can take you can multiply the equation by 5. If you do that, if you multiply by 5, so you have the equation number 1 implies that if you multiply equation 1 by 5, in order to remove this denominator 5, you multiply whole equation by 5. So you have 3t1 plus 4t2 is equal to 5000 G. And then equation 2 implies that you multiply equation 2 again by 5 to get rid of this denominator. So you have 4t1 plus 3t2 is equal to 0. And now clearly, if you need to find T1, which is the force acting along the cable AC, and in my assumption this is T1, so we need to find first T1. And in order to find T1, we need to remove or get rid of this T2. And how do you do that? The easiest way is you multiply this equation, the whole equation, by 3, the coefficient of that T2. And this equation you are going to multiply by 4 because of the other coefficient of T2. Then you have a same coefficient, and then you can subtract these two. I did a mistake here, sorry about that, I just forgot it, because this is minus, so it should be minus here, don't forget it. Okay, and then when you multiply, you have 91 plus 12t2 is equal to 15,000 G, and underneath you have 16 T1 minus 4 3s are 12 T2 is equal to 0. Now clearly you have opposite sign for T2's terms, so you can easily now add directly. You can cancel. You have 25 T1 is equal to 15,000 G plus 0, and then you have 15,000 G, and from here T1 would be equal to 5880 Newton. That's the value of T1, and then you substitute T1 in any one of the equation, either equation 1, equation 2, or either of these equations, and you can find T2. I'm just leaving it here, and you can figure out the value of T2, which is the force acting along the cable BC. Question number 4. Andrew hits a tennis ball vertically upward towards his sister Barbara, who is leaning out of a window 7.5 meters above the ground to try to catch it. When the ball leaves Andrew's racket, it is 1.9 meters above the ground and traveling at 21 meters per second. Barbara fails to catch the ball on its way up, but succeeds as ball comes back down. Modeling the ball as a particle and assuming the air resistance can be neglected, find the maximum height above the ground which the ball reaches. Now if you see the situation and if you're able to draw the diagram, the most important thing of these kinds of question is you must visualize the condition, and if you can draw the diagram, it will be a good help for you. So this is the ground, suppose, and here is the window. So this is the window, and this distance is 7.5 meter, and here is the racket, and this racket is 1.9 meter above the ground. So this is 1.9 meter, and the ball is leaving the racket with the velocity of 21 meter. So velocity at that point is 21 meter second inverse. So what happened when the ball leaves? The ball goes up, straight, and his sister was unable to catch, but it can catch when it is coming down here. So this is the situation, and we need to find, in part A, we need to find the total height gained by the ball or reached by the ball. That means we need to find the height from here till here. This is the height that we need to figure out in part A. Clearly you can see that you have initial velocity, you have acceleration, and you have the final velocity is 0. So you can figure out that first we need to find the height from the racket till the maximum one, and this height, let's suppose this height from here to here. This is S. So you know that you have a third equation of motion. You can use the equation and say that S is equal to V squared minus U squared over 2A, and then V is the final velocity when the ball is moving up here. So final velocity at that moment is 0. So 0 square minus initial velocity 21 squared divided by 2 into minus 9.8. So once you solve this equation, so your S would be equal to 22.5 meter, and then the total height H would be equal to 22.5 plus 1.9. That means the total height H is 24.4 meter. That's the height gained by the ball. Part B, find how long Barbara has to wait for the moment that the ball first passes her until she catches it. That means the situation is you need to find the time for the ball when the ball first passes from her and then reach again to her. That means you need to find the time from here, and it goes up and then comes down. In this interval you will have to find the time. So how do you do that? First of all, you can use the concept of the height traveled by the ball. No. Okay, let's see. We have this height from here, from window, from that point, and this height we can find after subtracting from 7.5 and the 1.9, and maybe we can use second equation of motion, so that we can have a time, because we have initial velocity here. Now what I'm doing here, because I have initial velocity at the start and I have this height, so using this height and the initial velocity, I can find the time when the ball reaches first to the window. And how do I do that? I can use S is equal to ut plus half at square. S is the height from the point of thrown to the window, and use the initial velocity. I can figure out time here. Now if you use this equation, so what happened now? Now look at the situation. So S, in this case S is 7.5 minus 1.9. If you do that, then S would be equal to 5.6. So you can use the second equation. You can say that 5.6 is equal to 21t plus half A. A is 9.8, and it is going up, so it is minus 9.8 t squared. That means it is 5.6 is equal to 21t minus, and if you divide 9.8 by 2, so it will be 4.9 t squared. And this equation is difficult to solve, but I can use the idea of the factorization. If you multiply the whole equation by 10, so you have 56 is equal to 210t minus 49 t square, and then you can take 7 common here. If you take 7 common, so you have 8 is equal to 30t minus 7t square, and then 7t square minus 30t plus 8 equal to 0. This is the quadratic equation. So you can factorize this equation, or you can use quadratic formula if you wish. So 8 times of 7 is 56, so you will have to break 56 into 2 factors so that you can have a plus minus 30. Clearly 56 making factor as a sum as a 30, so it is 28 and 2, so both would be negative in sign. So you can write minus 30t as 7t squared, so minus 28t minus 2t plus 8 equal to 0, and then you can take 7 common, 7t common, and then you have a t minus 4 from the first 2 terms, and from the second 2 terms you have a minus 2 common. Inside you have a t minus 4 is equal to 0, and then t minus 4 or t minus 4 equal to 0 or t equal to 4, and 7t minus 2 equal to 0, and then t is equal to 2 by 7. Now you have 2 values of time. So what is happening here? These 2 timings are basically showing the time for the ball to reach first from ground or from the point of thrown till the window first time, and the second time, which is 4, is the time when it reaches again to the window. So you have a 2 time. This is so clearly this is 2 by 7. This is the less time. This is more time. That means if you subtract these 2, so you have a time between the motion when the ball first passes from the Barbara and reaches again. So the delta t that she need to wait is 4 minus 2 by 7. That means it will be around 3.71 second. You can give answer in terms of fractions. So 7 times 4, 28 minus 2, 26 by 7, or you can give answer like that. Thank you very much for this video, and have a nice time.